Everyone. So in this video, we'll be tackling chunk 14.6, which is alcohols in topic 14 of your syllabus organic chemistry. Previously, we've seen alkanes and alkenes, which we call homologous series. Now we're going to have a look at what alcohols are, particularly ethanol, along with its common uses and famous methods of manufacture. So, as we said previously, chemists have grouped different organic compounds into families known as homologous series. Each homologous series shares some common properties, including they have the same functional group. In the case of alcohols, it's the OH group or the hydroxyl group. Since they have the same functional group, they will also share similar chemical properties. They will show a trend in physical properties in such a way that the longer the chain or the bigger the molecule size, the greater its boiling point, which makes sense as it's going to require more energy to overcome these bonds. And they will also have the same general formula and CH2 successions between the members. So, for instance, the first member in this series was methanol, and we said the prefix is an indication of the number of carbons. So meth means one carbon. The suffix is an indication of the group to which it belongs or the homologous series. So the suffix of alcohols is ol. So I can guess the next member in the series or the fourth member will be butanol, excellent, followed by pentanol, hexanol, and so on. Alright, we've also tackled different types of formula, and we said structural formula refers to the way the atoms in the molecule are bonded. So if I need to draw methanol, I will basically draw methane, which is CH4, and I will substitute the last or one of the hydrogens by an OH group. Similarly, ethanol was previously ethane with 2 carbons, 6 hydrogens, and I would replace one of the hydrogens with a hydroxyl. Now, this is another way to display the structural formula, sometimes referred to as the condensed structural formula, and you should be familiar with all sorts. The molecular formula, on the other hand, gives an indication of the exact number of atoms, the different atoms within the molecule. So for instance, methanol, it's CH3OH. It can also be written as CH4O. Ethanol would be C2H5OH or C2H6O. So if you have a look at this and you pause the video for a while, which general formula can you deduce from these compounds? So this is the correct general formula of alcohols. If I have an n number of carbons, so in the case of methanol it was only one carbon, the number of hydrogens will be 2n plus 1, so 2 times 1, 2, plus 1 is 3, and OH. Now one of the alcohols Cambridge is really interested in is ethanol. Among the uses of ethanol are that it's used as a fuel, it's also used in the alcohol industry. How can we prepare ethanol? We have two major techniques, the first of which is fermentation, and the second is by the catalytic addition of steam. In each type or in each method of manufacture, you need to illustrate the different conditions necessary for their reaction. And in the end, we'll be carrying out pros and cons or a compare and contrast between both techniques. So in the case of fermentation, which is the first method, I basically need glucose as my raw material or substrate in the presence of yeast as a catalyst and a suitable temperature of 37 degrees because yeast contains a biological catalyst or an enzyme, so to avoid its denaturation I need an optimum temperature, and I need airlock or anaerobic conditions, which is the absence of air. My products would be ethanol and carbon dioxide. Now, of course, in the presence of lime water, if I'm carrying out this practical test in the lab, the lime water, which is actually calcium hydroxide, will turn milky due to the presence of CO2. Now, one problem with the fermentation reaction is that the ethanol formed is actually impure, or it's a dilute sample. That's why this will require further processing by the fractional distillation process. Also, fermentation is not a continuous process. It eventually stops. Why is that? This can either happen when glucose runs out. So when I run out of the substrate, I can no longer produce ethanol. Also, the yeast can eventually be killed by higher temperatures or by the ethanol toxicity. Now, the second method to produce ethanol is known as the addition reaction. Now, if I started off with ethene, which is C2H4, and I add steam, my necessary conditions here are high temperature and pressure, so around 300 degrees Celsius and 60 atmospheres, in the presence of a catalyst known as phosphoric acid with a chemical formula H3PO4. So this is my ethanol. Now, addition reactions, if you remember, these are the type of reactions undergone by alkenes. What happens is the double bond is going to be broken, and I'll introduce the H to one carbon and the OH to the other carbon. Now, finally, this is a table of comparison between these two methods. So as I previously said, the fermentation requires glucose as its raw material, which is actually a renewable resource that will never run out. I can easily obtain it from sugarcane. Whereas the second method, which is the hydration of ethene or the addition of ethene to steam, the raw material comes from crude oil, which is actually in limited supply. It's a non-renewable resource. So fermentation wins in such case. We also said that the fermentation, on the other hand, as a con, it eventually stops, whereas the catalytic addition of steam is a continuous process and it's also fast. Moving on to the quality of the product, hydration of ethene produces the pure ethanol, whereas in the case of fermentation, as we said, it's a dilute sample that's going to form, so it requires further purification by fractional distillation. And as we've seen, fermentation takes place at 37 degrees Celsius, which is an advantage. This is a low temperature, but the second method, or the hydration of steam, requires much higher temperatures. So this is the end of the video. See you later.